Hello, welcome to this video. In this video, we're going to go through the topic of parallel and perpendicular lines in GCSE maths. So, parallel lines are defined, so if we look at lines that are just parallel, they're defined to be lines that will never touch. So we could extend these lines as far as we possibly want. We could go off for infinity. We can make these lines longer than the universe itself, and they will still never touch. Okay, so these things never touch. Okay, whereas perpendicular lines, what I mean by perpendicular is that they cross over each other at exact right angles. Okay, so being perpendicular means you cross over at a right angle. Being parallel means you never touch. So cross at right angles. Okay, now the use of these in maths is usually to do with solving some problems based on the equation of a line, so like y equals mx plus c. Okay, so if you remember from y equals mx plus c, this m stood for gradient. Okay, so m represents the gradient, which was the slope that it's on. So whether it's like this, it would have a higher m than if it was like this. So how can we relate these two things together? Well, if we have things that are parallel and they never touch, it means they have to be going at the same slope as each other for all of eternity. Okay, so the thing with parallel lines, I'm just going to redraw this in the center. So y equals mx plus c, where m is your gradient. With parallel lines, the gradients are equal. If lines are parallel, you have equal gradients. Okay, whereas with perpendicular lines, we can tell that these are definitely not equal. And in fact, trying to prove what the relation between these things are can prove to be quite difficult. But what you'll find is no matter what lines you have, as long as they cross over each other at right angles, let's call this line, let's have this line with a gradient that we're going to call m1, and let's have this line with a gradient we're going to call m2. If we did m1 times m2, it's always going to give you -1. Okay, for perpendicular lines, the product of the two gradients always gives you -1. Now, sometimes this is referred to as looking at the negative reciprocal. So they're the negative reciprocal of each other, because if I knew what m1 was, then I could work out m2 by doing -1 over m1. Okay, that's just by rearranging this formula here. So in terms of the types of questions they're going to give you, they might ask you to prove that these two lines are parallel, or prove that these two lines are perpendicular, or they might just ask you to use the fact that these lines are parallel or perpendicular to solve for some other problem. So in order to prove that two lines are perpendicular, we just have to prove that if we find both of their gradients, which you'll find out how to do in the y equals mx plus c, or the equation of a straight line video, we could find the gradients of both of the lines. If we multiply them together and we get -1, we've proven that these lines are perpendicular. If we find both of their gradients and their gradients are the same, we've proven that these lines are parallel because their gradients are equal. There isn't really much more content on parallel and perpendicular lines than this. It's really just knowing how to apply this, and applying this is what we're going to look at in the practice video. So we've said before, we have the two rules. If things are parallel, their gradients are equal. So if they are parallel, then the gradients are equal. And if things are perpendicular, then when you multiply them together, m1 times m2 must also always equal -1. So what they're asking in this first question is to write down the equation of a line parallel to y equals 3x plus 2. If you remember this 3 here, that represents the gradient, and so we just have to write the equation of any line that has a gradient of 3, and it will always be parallel. So we could just write y equals 3x, because this would mean that the y-intercept of this is just 0, and this would be parallel to this. You could write plus 3000, you could write plus 7, any of these would be perfect. Okay, so we could do the same thing here. We want to write down an equation that's perpendicular to the line that's y is equal to 3x plus 3. So if we know that m1 is equal to 3, then m2 is going to be equal to minus 1 over 3. So it's always the negative reciprocal. And so the equation of the line is going to be y is equal to minus a third x. And again, they haven't specified that it has to pass through any point. So we could put plus 7, we could leave it as plus 0. Either of these works. Okay, so now they're asking you to find the equation of the line that's parallel to 2y minus 3x plus 2 equals 0, and it passes through this point. So now they're specifying what they want the y-intercept to be. The first thing we have to do is rearrange this equation so we can actually find out what the gradient is. And so we want to rearrange it to be in the form y equals mx plus c. So we're going to move everything that doesn't have a y in to the other side. That's going to become that 2y is equal to 3x minus 2. And then divide everything by 2, so y is equal to 3 over 2x minus 1. Now we know the gradient is 3 over 2, so a line that's parallel to this is going to have the form y equals 3 over 2x, and it passes through this point. If we were to look where this point is going to be, it's where x is 0 and y is 4. This is the y-intercept, so we have to write plus 4. So they've specified it in this case, so we have to say that that's where it's going to pass through. Now we're doing a similar thing for this question, except they're perpendicular. So we need to divide everything by 5, so y becomes 2 over 5 x minus 4 over 5. And then if we want lines to be perpendicular, if we know this one, then m2 is going to be minus 1 over 2 over 5. Now when we do things like this, this is basically the same as just flipping this fraction and put a negative sign in front of it. So it becomes m2 is actually equal to minus 5 over 2, so minus 2.5. I'm going to leave it as a fraction, and they've told us the point that it passes through. So this has to be y is equal to minus 5 over 2x plus 7. So this is your perpendicular line to this equation here. And finally, this one is going to be the most difficult one that we're going to look at because we're being asked to use this idea that we know they're perpendicular to be able to work out what k is, okay? And to do this, we're first going to have to work out what is the gradient of both these lines. So line A passes through points minus 3, minus 1, and minus 1, 9. And line B passes through the points minus 2, 1, and k, 4. And we're being told they're perpendicular, and we want to find what is this value of k. So let's first find out what is the gradient of A. And to do that, we're going to say we know the gradient is the change in y divided by the change in x, which I'm going to write as y2 minus y1 over x2 minus x1. I'm going to label these, so I'm going to say that this minus 3 minus 1 is x1 y1, and that this minus 1 9 is x2 y2. It doesn't really matter again which way around you do these, you're going to end up with the same answer anyway, but I've just chosen this one arbitrarily. Y2 is 9 minus y1, which is minus 1, so this is going to become a plus, divided by x2, which is minus 1 minus minus 3. This is also going to become a plus. This becomes 10. This becomes minus 1 plus 3, which becomes 2. So our gradient of that is 5, which means we can then work out what the gradient of B is because we know they're perpendicular. So if m2 is therefore equal to minus 1 over m1, which is 5, then the gradient of B has to be equal to minus 1/5. But we can use this kind of same equational form here to be able to solve this equation for k. So we can say that let's call minus 2 and 1, and let's just put a 1 there. Minus 2 and 1 is x1, y1, and k4 is x2 and y2. Okay, now let's substitute it all into here. So y2 is 4 minus y1 is 1 over x2, which is k, minus 2, and this is going to be equal to minus 1 over 5, since this is the gradient of line B. Now cleaning this up a bit, 4 minus 1 is going to give me 3, so I could rewrite this as saying 3 over k, and this is going to become plus over k plus 2 is equal to minus 1/5. And now I just have to somehow solve this equation for k. So what I'm going to do is I'm going to cross multiply these things. So I'm going to multiply this up to here, and I'm going to multiply this 5 up to here. So this is going to become, actually I'm going to multiply this by a minus 5. So I'm going to bring the negative over here, so it just keeps my k positive. You could do it either way. Again, you'll get to the same answer, but this is going to become that k plus 2 is equal to minus 15. So I brought a minus 5 up here and a positive k plus 2 up here. And then to solve for k, this makes it much easier. I just have to minus 2. So k is equal to minus 17. And this is my answer. So I've used this idea that I know that the gradients of perpendicular lines are the negative reciprocal of each other to then be able to solve for a random coordinate given that I know its y value. So hopefully this helps you understand how to approach these perpendicular and parallel line questions, and thank you for watching.